Hello YouTube, welcome to very important tutorial on pointers. Now I do know that some people find this stuff scary, but don't be. Let me explain why. Just imagine that you at your disposal have really nice microscope and that you can zoom into layers of this chip on memory module. So just imagine that here you have thousands of intersections of rows and columns like wires, okay? So what is the purpose of those intersecting? The purpose is to have physical addresses of data that will roll through these chips. So you will probably say, well, I don't care about that. Well, here's the thing, if you are messing around with hardware, with C, with low-level stuff as programmer, sometimes you need to know what is at some physical address in memory or somewhere in your PC. So, question is, can we have ability in C++ to extract things that are rolling through these permanent addresses? Yes. So, we're gonna use pointers to get with our hand into those microscopic small places and to extract different things like variables, variable names, values, constant, and such a thing. It's really not important what is rolling through this hardware. It is important that we do have ability as a programmers with our source code, if it's accurate of course, to get into small bits and pieces and grab what is there so we can reuse it for some purpose. So that's the whole thing about pointers, physical addresses, and physical addresses are represented in your source code basically, in results as numbers. So let me explain with a couple of examples. So every time when you create variable like number and you give it a value like 1000, so this is something that you see on the screen, and when you run it you just don't care, you just care about end results. So those things will be useful for you or to your end user, but the thing that is important for machine is actual pointer, because then computer know where to go to get this stuff. So now this thing which is inside of this container is totally fine, but computer are more interested in where this thing resides so that computer can get there and grab this. So this container, just like in some supermarket, need to have physical address. Just like you in your house to have address, your house do have address, and all kind of people can roll through your house, like neighbors and girlfriends and boyfriends, whatever you do, and your cousins and such a thing. It's really not important. It is important that you or someone else can be in some point in existence of your house in that house. So if you sell it, that house will still have same number. So values like persons are not that important, they're just rolling through the house in different areas of existence of house, but the house as a physical thing is important. Why? Because it is in location in your town, and town is in state, and state is in continent, and those things matter. Now here's a question. So how to extract those physical addresses, those dedicated numbers, pointers? Well, we're going to use cout here, normal stuff, and you need to type number, and that's correct, and you can go to end line, that's correct. But here's the thing, if you wanna grab physical results and not actual values, they're not important right now, physical intersections of rows and columns, you need to use ampersand here. So let me find that thing on a keyboard if I didn't forget it. Oh yeah, there you go. So now when you save and execute this application, little script, there you go. So this is address inside of your PC of this container. So all kind of stuff can roll through that container, but this is address right now. So what's gonna happen if you change number here? Will this thing change like unique ID of container? Well, let's see. Let's just here remember a couple of things like 6 and EEC. So let's change this to 500 and let's run this stuff again. And there you go, nothing's changed. So 6 EEC. So DF, let's say, will that change if we change this stuff again to 100? So what was it? 6 FC EEC, I think, or EFD? DF? Yeah, DF. And let's change this stuff again, like a 5. And let's see what's happening. So see, DF, that thing doesn't change, no matter how you messed up this value. Right, so can you in the same like piece of code use both of these? Well, sure. You can, when you are practicing, use this stuff. Like you can grab actual value and you can grab permanent pointer, permanent physical address. There you go. So in your case, of course, this number will be different. I mean pointer, because our machines are different and we are running this code into different time, space, dimension, and you're using a different variable and different value and such a thing. It's really not important. So here's a question. Can we use these pointers differently? Like, why do we need all the time to write when we need it? Like ampersand and number, like 100 times? Well, no. We can actually extract this stuff and put it somewhere. So let me explain. Every time when you wanna grab pointer and put it somewhere in dedicated container for that address. So remember, now we are creating thing that will hold this address. You're gonna do this integer, okay, and now pointer to number. And how to get it? You're gonna say ampersand, because this is how we get pointer. I always forget where is that thing on the keyboard. So 7, okay, shift 7. So number, and because this is instruction, we need to end it with semicolon. But right now, there is something else that we need to add here. Every time, and remember this, every time when you're grabbing physical address with ampersand, you must also here use star. This is very crucial to remember. So, okay, you can grab address, but where to put it? Into this container, this name with a star as a prefix. Okay, so remember that is very, very important. Now, here's the thing. How to use this stuff? Do we need to use star every time when we print this pointer? Well, let's test that. Cout and pointer to number and end line, and let's compare this thing to this thing. Are they the same? Well, there you go. They are same, and this is just a value. So please note, when you're extracting pointer, I mean address, okay, address of the thing inside of your PC, you're gonna use ampersand, so you can grab that result and put it into here. So every time when you create pointer, create it with a star, but when you are using it, okay, remember this, when you are using it, do not use star. It's already done here at the top. So here's a funny thing. Can we have multiple pointers to same address? Like if we ever need that? Well, let's test that. So for example, here we are going to say integer, and where is that thing on a keyboard? Okay, pointer number 2, let's say, equals, and we wanna grab same address. Okay, so we have it, so let's use it, and I'm gonna steal for time saving purposes this this line. So what we are grabbing is, printing pointer to pointer number 2. Okay, so now we can also use it, no problem, and we will get same stuff. So see, there you go. Now often when you're practicing, if you're a beginner, just use one pointer to that specific physical address and you will be fine. Okay, don't confuse yourself. You can have 10 these, but there is no purpose, well, at least for now. So I don't want to confuse you. As I said, just use one pointer and then do something with that, what we are going to learn in a couple of next tutorials. Now this is very crucial to understand, very important, because always in C and C++ you're gonna use it. Let me think, do I need to say something else here? No. So bottom line, if you want to grab physical address, use ampersand and the variable name, and you can put that result inside a pointer. And when you are creating it, use a star. When you are using it, do not use star, use just a name. Okay, and the purpose of all that story is just to track what kind of values are rolling through that physical address in a memory, like your own precise, very effective microscope. Anyway, I'm gonna shut up here and render this video. Thank you for watching. See you next tutorial.